Hello, today we're going to do problem 1.6 from Fundamentals of Heat and Mass Transfer 7th edition. And the problem says, the heat flux through a wood slab 50 millimeters thick, whose inner and outer surface temperatures are 40 and 20 degrees Celsius respectively, has been determined to be 40 watts per meter squared. What is the thermal conductivity of the wood? So, we will start with our knowns, and we know that the heat flux Q double prime sub x is going to be 40 watts per meter squared. And you know what? I'm going to erase this little dash here because it looks like a negative. And I knew to put the x here, or excuse me, not the x, the double prime, meaning that it's per area because our units were in meters squared. And because it said heat flux and not heat transfer, which would have been in watts. We know that the thickness, we'll call that T equals 50 millimeters. I'm going to go ahead and change that to 50 times 10 to the minus 3 meters to put that in SI units. We have T inner at 40 degrees Celsius and T outer at 20 degrees Celsius. And we need to find K, which is going to be the thermal conductivity of the wood. So let's go ahead and draw our schematic. We are just going to draw a little box here, representative rectangle. And on one side, we will have T inner, and on the other side, we will have T outer, and I'm drawing that a little bit lower to represent the fact that it is a lower temperature. I'm also going to draw a line between them. And I'm going to call that line T of X, where the X direction is this horizontal direction in our image. I'm going to draw a little squiggly line for our heat flux, and that is Q double prime sub X equals 40 watts per meter squared. And the last thing I'll write is this wood is gonna have thermal conductivity K. We just don't know that yet. So that's our schematic. Let's go ahead and write down our assumptions. And those are going to be 1D conduction in the X direction. Right, and we don't have any information about the y or z direction, so it wouldn't make sense for us to analyze anything there. As usual, we are also going to have steady state conditions and constant properties. So that thermal conductivity is not going to change even if the wood changes temperature. We'll move on to our analysis. Gotta find the top of the page. And we can solve this problem using Fourier's law, right? Which says that Q double prime sub X, so we won't have the area, is K dt dx. We're going to rearrange this equation to get K on its own. And that means K is going to be Q double prime sub X times dx over dt. And I'm going to write this a little bit more explicitly. The Q double prime sub X we can't change, but dx we're going to rewrite as L and you know what? I forgot to write that in our schematic, so maybe some of you caught that. We need to put L here. And we also know L, except I called it T. Double mistake. So we'll call it T for the thickness, and that's 50 millimeters. So T is, I'm just going to write this here to remind ourselves, thickness. You could call it length. I don't think anyone would mind. And then dt is going to be the T inner, that higher temperature, minus T outer, that lower temperature. And from here we can solve. So Q double prime sub X is what? 40 watts per meter squared. our thickness is 50 times 10 to the minus 3 meters. And T in minus T out is 40 degrees Celsius minus 20 degrees Celsius. And if you do that math, that's going to turn into 0.1. And we might be wondering what the units are. Well, we have a meters on top here and a meter squared on bottom here. So we can cancel out one of those meters. We have watts, that doesn't cancel anywhere. We have a meters on the bottom, that doesn't cancel anywhere. And we have a degrees C on the bottom here. But it's a little bit more common to use Kelvin, actually, in heat transfer. And since we're looking at a temperature difference, and temperature differences are going to be identical in degrees Celsius and degrees Kelvin, since the difference between them is adding 273. 0.15. Our units here are going to be watts per meter K. And I suppose you could write watts per meter degrees Celsius, but that doesn't look right to me, so I'm not gonna. And the last thing I'll write is our comments, and explicitly, I'll just write that for a temperature difference, sorry if you can hear my cat's fish in the background. Kelvin is equivalent to degrees C. So they may be used interchangeably. And that's the problem.